On April 25, 2015, a magnitude 7.8 earthquake struck Nepal just 77 kilometers northwest of Nepal's capital city, Kathmandu. Being situated along the boundary of the colliding Indian and Eurasian plates, Nepal is no stranger to earthquakes and is continuously affected by the hazard. However, this earthquake, known as the Gorkha earthquake, is the second largest earthquake to hit the area in the past century, delivering a high number of fatalities, injuries, and infrastructure damage. What makes the Gorkha earthquake also notable is its magnitude 7.3 aftershock, which occurred the following May 12th, which only added to the destruction of the already battle-scarred Nepal.
The underthrusting of the Indian plate beneath the Eurasian plate has led to the creation of the Himalaya as well as many active faults in the area. This has allowed for shallow and devastating earthquakes to occur throughout Nepal and surrounding areas. This is the same for the Gorkha earthquake that occurred in 2015. With a depth of only 7 miles, which is rather shallow in geologic terms, the Gorkha earthquake recorded a moment magnitude of 7.8 and was able to travel long distances with devastating effects. The farthest the earthquake could be felt was in Kahuta, Pakistan. This is nearly 1,500 kilometers away from the epicenter, near Kathmandu, Nepal.
The country of Nepal is positioned along the Himalayan mountains, an area where surface-rupturing thrust earthquakes occur on land. The formation of these mountains began with the collision of the Indian and Eurasian plates. During the process of the Indian plate being subducted beneath the Eurasian plate, parts of the sedimentary coverage detached and underwent metamorphism to accrete at the base of the Himalayan wedge and form the Lesser Himalayan duplex. This later resulted in the Lesser and Greater Himalaya. As convergence continued, 3 major fault zones were created and exposed along the entire Himalaya. These fault zones merge into a joint decoulement called the main Himalayan thrust. Reviewing the seismic history of Nepal would reveal that large magnitude earthquakes are common in the country. This is a result of the ongoing collision of Eurasia-Indian plates creating active faults. With such a dynamic tectonic history and current plate activity, it is easy to see how such a huge earthquake could have occurred in Nepal.
The seismicity of the Himalayan region is a result of the continental collision of the Indian and Eurasian plates beginning roughly 50 million years ago. The underthrusting of the Indian plate creates a substantial number of earthquakes, meaning this plate boundary is one of the most hazardous regions on Earth. The subduction of the Indian plate beneath the Eurasian plate occurs at a rate of 45 millimeters annually, a rate much lower than that of the plates prior to the continental collision. The 2015 Gorkha earthquake and its aftershocks were a result of thrust faulting in the Indus-Yarlung-Suchar zone, a thin east-west region spanning roughly the length of the Himalayan ranges. This northward underthrusting of the Indian plate beneath the Eurasian generates numerous earthquakes, and with such strong tectonic activity, the Himalayas continue to grow each year.
This shake map, provided by the USGS, shows the severe shaking that could be felt around Kathmandu. As the quake moved away from the epicenter, it dampened quickly, going towards the north due to the obstruction by the mountains. The shaking stayed stronger for much longer, going southward away from the mountains.
With Nepal's long and active tectonic history, the occurrence of an earthquake as strong as the Gorkha earthquake is not an unusual one. From the collision of the India and Eurasia plates leading to the formation of the Himalayas, moving ground has been prevalent in the region. Generations of people in the area have grown to learn how to live around earthquakes. However, there is room for improvement. The magnitude 7.8 earthquake just made more earthquakes possible, meaning that steps need to be taken to reduce their impact. Overpopulated areas with poor buildings are common in the area and are the most at risk. With better structures and warning processes as well as education, the devastation that comes with earthquakes and the hazards that follow can be reduced.